Okay, so our big difference today for solving equations is that we could get some special solutions. So let's kind of go through what things we need to look for first when we're solving our equations, okay? First thing I want you to do is look to see if you have any parentheses that you need to distribute a number through, okay? If you don't, that's fine. I then need you to look for what?
Exponents.
We're not going to have exponents, but I appreciate the thought. I think you're going back to our order of operations. It is possible that we have like terms, okay? Combine like terms on the same side of the equal sign, okay? I wish I could change that. You get to leave, I don't. Yes.
What about rearranging terms?
And that can be done within this step too, okay? So you can rearrange and then combine, or if you want to just combine without rearranging, that's okay too.
Can you do rearranging as your first step?
You would probably want to distribute first if there were parentheses. So you can get that through.
Okay.
Are you with me?
Not really.
Like if we have 5 times x plus 3 minus 2 equals 5x. You would have to do this before you can rearrange.
Okay.
Okay. Okay. All right. Then we can start moving things to one side or the other. It is in your best interest to move the variables first. Move your variables to one side. Move your constants to the other. It is in your best interest to move your variables first. Okay. At this point, if you have like 5x equals 45, we have x's on one side, constants on the other, then you can divide by the coefficient. And you should have x equals. Okay, now none of that should be new. Okay, something that is maybe a little strange is we might not always have an answer that works, or we might not have just one answer that works. Okay, if we come down here, okay, obviously we know that we could get one solution for our problem. That's what we've been getting for the past 3-4 days. But it is possible to have an infinite number of solutions or no solution when we solve an equation. And I'll explain to you what those look like, but let's just write down the 3 first. Okay, if we have one solution, then we're going to get an answer. Okay, x equals 5. x equals 15, x equals negative 2/3. We're going to actually get an answer. Okay? However, when we have infinite or no solutions, it's going to be a little strange at first because what's going to happen? The x's are going to go away. They're going to disappear. Okay? So if you get your x's to disappear, but you get something like 7 equals 7. Is 7 equal to 7?
Yeah.
How often?
All the time.
All the time. We're going to get something that's always true. It is true an infinite number of times, aka always. Okay? So if your x's poof disappear, they cancel each other out when you're balancing your equation and you get a true statement. That means anything that we plug in for x is going to work. There's an infinite number of solutions. Okay? But if our x's cancel out and we get something like this, how often is 0 equal to 5? Never. Okay? If we get an untrue statement or an untrue result, we're not going to have any number that we could plug in for x to make our equation true. Okay, I know that sounds weird, right? I'll show you what that looks like, but it is possible to have equations that don't have an answer. And it is possible to have equations that have an infinite number of solutions. Anything you plug into it is going to work. Okay. Okay, so what I am going to do, I'm going to give you a little bit of time at your table to work on giving me answers. If you go to the next page, if you go to the next page, I want at your table to work together on getting me an answer for number 2, number 4, and number 5. Based on the skills we worked on last week, all of these have just the one solution. You should get an answer for all 3 of these. I'll give you about 5 minutes to work through these 3 problems. Ready, set, go.
Just plus 5z.
Yeah, so we just add 5. Like,
No, the other side.
and use this. So it'd be like 10.
On number 2, should we add 5 first? Like bring the variables to the right side?
If you're bringing the variables to the right side, you would add 5.
But which should we
You could do to the left or to the right. In this situation, 6 one way, half a dozen the other. Like, it's not going to save you any time to do one person.
I got a very might be D. Let's try number 4. That one looks weird.
I wrote something on the board that might help you as you're working on it. Do we need calculators? Blue table, take one.
That one took me so long.
If you need one, take one, pass it back. If you need one, take one, pass it back.
It's what I said. You just take the number, divide it by the 4, and then multiply it times 3. Well, that's how math works. Yeah, it is. Isn't that what you're supposed to do?
Okay, hold on.
Well, it is.
This one?
She said it was.
Okay, which side do you want your z's on? Okay, so since this is minus 5z, let's plus 5z on this side. That way it's not over here. So plus 5z. Okay, so now over here we have 7 equals. And then on the right side we would have 17 plus 10. So now I want this to not be over here, so how would I get over there? Would I add it? And it would cancel out? Would I subtract it? Okay, so we were to subtract 17 to make it go away. We took it.
Oh, wait. She answered?
So what are you doing with both sides here?
Yay, I got them all right.
Adding what?
What is that?
Okay, so you added 5 places.
It's so itchy right now. It's not good.
You got it. Yeah.
I don't know why I erased all that.
What? You add the yeah, you can just do that. As long as it has a plus in front of it, you can just do that. It doesn't matter if there's so it's basically just 3 keywords.
So you're moving the 3 minutes. So if I add 36 plus 36 0. Okay. So that's what you gotta ask yourself. Is it
What's negative? When I add 18,
You're just trying to.
Why equals
no, it's
no? What's 11 times 11? Okay, that's what I thought. I wasn't sure. I'm pretty sure it's 121. Let's
I
go
got
on.
126 equals 32.
You should know this one off the top of your head.
What?
Is that cardboard boxes?
I mean,
I like
got
cardboard.
they're we're getting new like printers.
Oh, I see.
Yeah.
Should use those boxes for something. Like a box. Or like you have to build a box. You know, like at the assembly, you have to build the biggest box for with the boxes. Yeah, I'm guessing that would go absolutely horrible. Yes, give children cardboard and duct tape. See what could go wrong.
Okay, I know that some of you have not finished all three, and I'm totally fine with that. Okay? Let's talk about number 2. Okay? Raise your hand if you put the z's on the right side. You moved the z's to the right side. Raise your hand if you moved the z's to the left side. Okay, not everybody did the problem, so we're going to try this again. How many of you put z's over on the right side? Left side. Okay. It does not matter. We get the same answer. Okay. So if we move z's to the left side, we would have to subtract 5z so that these would cancel out to be 7 minus 10z equals, 10z, that's a fun game, 17. Now, if I want to move this 7, is adding 7 or subtracting 7 gonna get me 0? Subtracting 7. So we have negative 10z equals 10. When we divide by negative 10, that's how we get our z equals 1. Okay? If you put the z's on the right side, then you had negative 10 equals 10z. And then you divide it by 10. Okay? Now, let's talk about this problem. Please do not let fractions intimidate you. It's actually nice because both of these numbers are divisible by 4. So multiplying by 3/4 isn't that bad. Okay? What happens when so we have parentheses, which tells us we have to distribute. What happens when we take 3/4 times 48?
27.
We get 27. I mean, you could. We get 27, and then 3/4 times 16x. Is that 12x?
Yeah.
It's not 27?
It's 36. We took 3 divided by 4, and that got us 0.75, and then we multiplied that by 48.
Or you can say 48 divided by 4 is 12 times 3 is 36.
Doing the decimal plot.
Okay? All right. Now, yeah. Hey, mistakes are totally fine. Mistakes are totally fine. All right. 4 times 4. 4 times 2x.
8x.
Okay. Raise your hand if you moved the x's to the left side. Raise your hand if you moved the x's to the right side. Okay, not everybody did the problem. That's cool. That's cool. Out of the 3, this was probably the most intimidating. So if you skipped one, it was probably this one. You didn't have time. So, who wants to put it on the right side? Who wants x on the left? Okay, I have more people for the left. So I'm going to subtract 8x so that these undo. And we have 36 minus 20x equals 16. I know some of us are having trouble. I don't know whether I should add or subtract 36. Well, this is what you ask yourself. If you add 36, does that cancel out? No. So let's minus 36. So we have negative 20x equals negative 20. So when we divide by negative 20, that's how we get our positive 1. Okay. Well, since you have a calculator, it probably is not that big of a difference. Okay? The time you cannot do a decimal, though, is if it's like 1/3. You cannot just put 0.3 because that's not the same. Okay? All right. Now, in number 5, I don't see any parentheses, which means we don't need to distribute. However, there are like terms, Rachel Brown. Thank you. I think that the left side is fine. But the right side, we have 2Q and Q that we need to add together. So do you have this? Yeah? You have that?
I sort of. Wait, you put a 3 in the Q. Oh, you added the Q.
Yeah. Yep. So now, I would prefer you to, I think it would make most sense to put the Q's on the left side because it's going to give us a positive coefficient. Okay? So Miles, how are we going to move 3Q over to the left? Okay, so we're going to subtract 3Q from both sides, so these go away. And we have 2Q plus 6 equals this minus stays with the 2. You see that? Okay, now we're going to have to subtract the 6 over so that 2Q equals negative 8. So now when we divide by 2, there's our negative 4. Okay. Light bulb. Okay, now if you made a mistake during any of those 3 problems, it's cool. We're still working on it. Okay? If you got there, good job. Okay? Okay, before we get to infinite and no solution, I want to go to the next page and look at number 10. Okay? I worry about problems like number 10 because what number are we distributing over here on the left side? Ah, this is a minus 8. We're going to view it as a negative 8. So when we distribute for our first step, on the left side, we have 3x minus 16x, but then that negative 8 times 3 is minus 24. And that's a really easy thing for students to mess up because it's easy to forget about the negative 8 times 3 with the sign changes. Okay? I can hear some of you already working on the next distribution. David, what do we get when we distribute negative 6 through that?
12x, negative 12x, and 30.
And is it negative or plus?
Negative.
Okay, so negative 12x minus 30 is what we should have on that second distribution. Okay? Now, this problem has it all. We have like terms we have to combine, don't we? Yeah. Over here on the left side, we have 3x minus 16x. That gets us negative 13x minus 24 equals negative 12x minus 30. Does anybody have any strong feelings about where we should move the variables?
We should move the variables to the left side. Yeah.
Left side? Okay. So to undo minus 12x, we're going to have to add 12x. Which means now we have negative 1x minus, or negative x. You would not necessarily need the 1. equals negative 30. 1x and x mean the same thing, so negative x and negative 1x. If you have the one, cool. If you don't, you don't need it. Okay. Now, what do we do with the 24 to both sides?
We would add 24.
Yeah. Ugh. So now we have negative x equals negative 6. Is that my answer?
No.
So technically, we would need to divide by that negative 1 so that we get a positive x. In this case, equals a positive 6. Huh is right. Okay, are you ready for the fun? Okay. Okay. Number 11. It actually saves us a lot of work when we have no solution or infinite solution, okay? So, number 11. Our first job is to do what? All right, let's do it. We have 24s plus 72 and 24s minus 6. And some of you are already thinking, ooh, I see something. Okay, so I want to move, and this is why I'm saying move the variables first. I want to move my variable to the left side. So how do I undo this guy over here? So you're saying I should add 24s? Okay, we need to subtract 24s. Okay, cool. So those go away. Uh-oh, what happens? Aubrey, how often does 72 equal negative 112? Never. So we have no solution because 72 does not equal negative 112. Yep, it doesn't matter, Kit. They're not equal, there's no solution. Do you see that just cut our workload like in half, didn't it? Yeah. All right, let's see what happens in number 12. Okay. It appears that in number 12, I don't have to do anything on the left side. But on the right side, we need to distribute. Interesting. It's totally the same thing, isn't it? Okay, so if I go to move my variables to, let's say, the left side, then how would I get this 16f to the other side, Connor? We are going to subtract 16f from both sides. And when we do, the f's on both sides cancel, and we have 24 equals 24. Savannah, how many times does 24 equal 24? All the time. So we have infinite solutions. Pretty great, right?